Take this last. Welcome to our tutorial of Proflearn YouTube channel. In this particular video, we're going to have a discussion on the main topics that you really need to prepare as far as May-June exams is concerned, and we're going to focus on the topic, we're going to focus on the subject physics IGCSE 0625, so that we can be able to see which are the main topics you need to prepare as far as that exam is concerned. If you're new to Proflearn YouTube channel, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. So on Friday, you're gonna sit for this paper. One of the area that and one of the topic that you really need to prepare on is the topic of light. Light is a wave, and which is an electromagnetic wave. Visible light is an electromagnetic wave, and which will mean that we shall be asked various properties of light. Light can be reflected, light can be refracted, and light can be diffracted. So we're going to look at the topic light waves, and you can see one of the questions that can be asked here is whereby you are given a concept of light passing through an optical fiber, and you are supposed to work out the critical angle. And remember, critical angle is the angle of incidence in the dense medium when the refracted angle is 90 degrees, and the relationship that exists between the refractive index and the critical angle is this relationship that we have at this given point. So we are going to use sine of angle of incidence is sine of the critical angle is equals to 1 of the refractive index. And at that point, we're going to say, for us to find C, we're going to say sine inverse of 1 over the refractive index, which was given in this question as 1.46. So if you work it out, you are going to get 3 degrees, and we are going to transfer and write our answer there. Another concept that you may be asked is to state the purpose and the use of the optical fiber. Remember, optical fiber can be used in communication for carrying signals, and it can also be used in hospitals as an endoscope. So maybe another question that can arise here, they may ask you what is the advantage of using an optical fiber in passing information. Optical fiber has low resistance, and also it can carry a lot of data. It can be able to transmit a lot of data from one point to another. Another question that will arise, and a question that you may be asked, is about lenses, whereby you are supposed to construct the images of a lens. You are given data, you are given a diagram there, and then you are supposed to locate the image. Now, the first thing that we need to accept here is that if this is the object at this given point, for us to determine the image, there is a ray that is running from the top of the object, running through the center of the lens, like that, and there is another ray that is going to run parallel to the principal axis. So this ray is going to run parallel to the principal axis. The moment it reaches, it hits the lens, it's going to be refracted such that it passes through the principal focus, yes, such that it passes through F. But you see, these rays, two rays are diverging. We can see these two rays are diverging from each other, so which means the two rays will never meet at any given point. So since the two rays are not going to meet anywhere, then we are going to extend them backward so that we can be able to locate where the image is. And you can see that's why in this worksheet I did extrapolate the rays backward, and they're going to meet somewhere here. So the point where they are meeting at this given point, it means that's where the image is going to be formed, and we now going to label that as what? As I. So let's see, because we are told that these tiny small boxes, 5 of them represent 1 centimeter. So on the diagram, continue the part of these two rays. There is a ray that was given here, and this one that was given. Then meaning we were to extrapolate the rays backward so that we can be able to have our image using find the mark on the diagram I. You can see I labeled that I like that, and then I labeled the image I there. and then we were supposed to determine the height of the image. How do you find the height of the image? We were told that one square, this one here, we have this, this is 1 centimeters. So how many are they? 1, 2, 3. And how many tiny boxes? 1, 2, 3, 4. So meaning that we are rather 18 tiny boxes. So we are going to say that 1 centimeter is equals to 5 small boxes. What about 18 of them will be how many centimeters? Because from here, this is 5, this is 10, 15, 16, 17, 18. 18 will be what? 1 centimeter is equal to 5 tiny boxes. What about 18 of them? So that's the small mathematics I did, and I got my height to be 3.6, and that will make you to earn a mark at that point. So at this given point, let me say that if you are new to Proflearn, let me say that at this point, if you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to create another tutorial, you'll be notified. And if you have not joined our Patreon page, take this chance to check in the description so that you can be able to join our Patreon page, so that you can be able to download some of this marking scheme and this worksheet I'm talking about here. So let's go straight and continue with the next part, whereby you are supposed to state and explain whether the image formed is real or virtual. So you need to understand what we mean by real and virtual images. So if you look at the image that we formed here, the image was formed by imaginary rays. So if we are saying that this image was formed by the imaginary rays, these imaginary rays that we have in here, so we are trying to say that this is a virtual image because it formed by virtual images. It's formed by virtual rays, right? So we're going to say this is a virtual image because it formed by virtual rays. And in that way, you need to remember that you may be asked about characteristics. So characteristics of this image that has been formed here, we're going to say is a virtual because formed by virtual rays. It's upright because it's in the positive sense of the object is upright. And we can also say it's magnified because if you look at the object and the image is bigger, so we can say this is magnified. Right, so I think we are done with that. We can move and move to the next question. The next question is about refraction, and we are told that red light traveling in air strikes the curved surface at a semicircle. This is now a semicircular block, and we are supposed to explain why light does not change the direction as it enters the glass block at P. Why is it changing the direction? Why is it not getting refracted when it's passing through P? This is because the ray OP is at right angle. It's at 90 degrees. It's along the normal. It's at 90 degrees in this particular part. So it's meeting the glass block at a right angle. So which means the angle of incidence at this point is 0. The angle of refraction also will be 0. So this ray is not going to undergo any refraction at that given point. Now, part B, the light travels in the glass to Q, where it strikes the edge at 30 degrees to the normal. So we are told, you can see the angle that we're talking about is this 30 degrees to the normal. And we are expected to calculate the angle between the normal and the ray in air after the light emerges. So at this given point, we need to work out this angle that we are having here. So this ray is moving from glass to air. So hoping that if this ray was moving from air into glass, it will follow the same path and that is according to the law of reversibility of light. So if we are having this light going back, it will follow the same path, and we are going to have this angle that we are having below here. If the ray is going back, we are going to have this angle, we can call it incidence, and inside here we can call it angle of refraction, so that we have the ray moving from air into glass. Then I'm going to say that sine angle of incidence over sine r is equals to n, which is the refractive index, and the refractive index in this question is given at this given point. So what does that mean? We are going to consider that t as the angle of refraction and I as the angle of incidence, and then we are going therefore to substitute sine I over sine that is equals to 1.5. Then we can be able to make I the subject of the formula. Of course, if you take whatever we are given here and we multiply sine that both sides, we shall have sine I is equals to 1.5 sine that t, which means if we want I, we shall find the sine of inverse of the all of the result that we have at this point, and that angle becomes 48.6, which is approximately 49 degrees. Now on the diagram, sketch the path of light in the air after it emerges at Q. So this ray that we are having here was not there, so the ray had stopped here. So this is the ray that we were to draw to answer that question, and you can see the angle of incidence when the ray is emerging the glass out of the glass is larger than the angle of incidence here is greater than the angle of refraction down here. Yeah, so that because light is moving from a dense medium to a less dense medium, so if light is moving from a dense medium to less dense medium, it will speed up and bend away from the normal, and that is why we are going to work it out like that. Now the direction of light striking the curved surface of the glass block is changed, and the angle between the ray and the normal at Q gradually increases from 30 to 90 degrees. So basically what the question is saying, trying to say, we are having this ray here like that. So this angle of incidence inside is increasing. So if this angle is increased, the angle of refraction down here also is going to increase. So meaning the ray is going to bend towards the boundary like that. So it will reach a point where when the angle of incidence is greater than the critical angle, then total internal reflection will take place. All the rays will be refracted internally. So let's see how you are supposed to structure your answer at that given point. So we are going to say here that as the angle increases, the angle of refraction also increases. As the angle of incidence increases, the angle of refraction also increases. The reflected ray becomes brighter, and when the ray of light then the ray of light is going to be reflect back into the glass when total internal reflection has occurred. Have you subscribed to Proflearn? If you have not, you need to do that, so that when I'm going to do more of the topics that will be tested, you'll be notified. So we are going to look further and going to look at the images formed by, we shall look at images formed by mirrors. Images formed by mirrors. The image formed by mirrors are actually visual images. They are imaginary images. They have the same size, they have the same distance, they are in the same distance behind the mirror as the object is in front of the mirror. Question number 6 is we are told that the distance between the center of a converging lens and each principal focus is 5 centimeters. The lens is used as a magnifying glass to produce an image I. So we have the image I at this given point. So if we are told the principal focus is 5 centimeters, so meaning 1 centimeter square, we can count 5 of them so that we can be able to locate where the principal focus is, the principal focus at this point. So you can count 1, 2, 3, 4, 5 boxes will give you where the principal focus. So you locate the first principal focus and also the second principal focus, because a lens has got 2 principal focus. So in that way, if we want to locate the object, because basically this question is whereby you are on the diagram marked both principal focus, we have done that, and then you are told by drawing on the diagram find the position of O, object O. So we are given the image, then we are supposed to locate the object. So how do you approach those kind of questions where you are given the object, the image, you are supposed to state the object? Now, to do that, the first thing that you need to realize, is that whenever you are constructing the image, what you need to understand is that whenever you are constructing the image, when you have the object, is that there is a ray that is running from the lens, center of the lens, to the image. So you will draw a straight line running from the image through the lens like that. And also you need to remember there is a ray that's running from the principal focus right to the image. Then you draw that line like that. Right? Then once you have that line from the image through F, and where it meets the axis of the lens, then you, at this particular point, you are going to draw a line that is parallel to the principal axis. Of course, remember we have our principal, this is our principal axis here, right? This is our principal axis. So which means from this point, you draw a line that is parallel to the principal axis. Where that line meets this line that is running this way, that is where the tip of the object is. Then our object will be located at this given point like that. So basically, you are reversing the process of constructing an image, right? So I believe we are together up to that point. And using the diagram, determine the distance of the object from the object. So if we know that 1 square represent 1 centimeter, then we're going to count how many squares do we have. This 5 square do we have. From here to here we have 1 centimeter, 2 centimeters, then 3 centimeters is the point, the distance we have here. So basically those are the questions that you can be asked for lenses, how to construct an image, stating the characteristics of the image formed, and also you can be told to locate the object when you are given the image, or you are told to locate the image when you are given the object. So let's look at the next question that was also asked in one of the year. Is a question here. You are given the object here, and then you are supposed to draw and locate where the image is. So the first ray is a ray that is running through the center of the lens, and that ray moves like that. You can see this ray is going to move that way. And another ray is a ray that's parallel to the principal axis. The moment it meets the lens, that ray is going to be refracted such that it passes through F, isn't it? And then if you want to locate the image, you are going, because these two rays that we are having here, you see these two rays are diverging. The rays are diverging. If the rays are diverging, then we are going to extrapolate these rays, and we are going to are not going to meet. They are diverging. So we have to produce them backwards so that we can be able to have our image formed at this given point here. Yes. The next part that we are being asked, state and explain whether the image is visual. Basically, we have answered that question. The image is visual because it's formed by imaginary rays, and the name, state the name given to the lens when it's used in this way. The name is a magnifying glass, because you can see the image is larger than the object. So if we are having the image being larger than the object, then we can be able to say that this can be used as a magnifying glass. So if you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to add more tutorials, you'll be notified. At this given point, join our Patreon page so that right. So conditions for total internal reflection is another area that you may be asked. So if you have a ray moving from a dense to a less dense medium, that's one of the conditions. The ray must be moving from a dense to less dense medium. Number two, the critical angle must be the angle of incidence. The angle of incidence must be greater than the critical angle for you to earn those marks for total internal reflection to occur. So the most important concept that you really need to remember as far as this topic is concerned, number one is the formula, using the formula sine I over sine R. This is one of the first formula that you need to remember for this concept. And you need also to remember that refractive index is speed of light in vacuum over speed of light in a medium. So the second formula that you are going to remember for you to answer the coming exam on Friday is this. And then you remember that sine C is equals to 1 over N, or N is equals to 1 over sine C. So these are the main, the three main formulas that you need to prepare as far as that particular exam is concerned. So the next tutorial that we are going to focus on is on electricity. So if you have not subscribed, subscribe so that when I'm uploading electricity, you can be able to be notified. Check in the description, you'll see the link that's going to take you to electricity, so that whenever you're going to do that exam, you're going to be notified. See you. All the best. Good luck, guys.